Well, happy Tuesday. Sorry I can't be with you guys today, but I am with my youngest son, Paxton. He's getting tubes put in his ears, so I had to take him to Sugar Land for that small surgery. But I trust you guys are being on your best behavior for our substitute teacher, and that you are going to do your work beautifully today. So today we're going to be learning a quick lesson on scientific notation. You should have this pink paper out in front of you. Scientific notation, even though it has science in it, it really is more math than science. It has really nothing to do with what you know about science. It is just a part of math that is called scientific notation. And what it is, it's taking a big number or a big decimal and making it smaller and using powers of 10, okay? So if you look at the example in number 1, we're taking a number and we're putting it into scientific notation. Right now, that number is in what's called standard notation. It is 6,224, and the decimal is at the end of that number because it is a whole number, okay? So the goal of scientific notation is to have a number, then and then just one number, and then a decimal, and then all the other numbers can be after it. Okay, so you want just one number and then a decimal. Okay, so here we have the decimal at the end. So we're going to have to move this decimal over till it is one number, the 6, and then the rest of the numbers. Okay, and when we do that, we move it over 1, 2, 3 places. That's 1, 2, 3 places. So this 3 is going to be my new exponent. So our new number in scientific notation, it becomes 6.224 times 10 to the 3rd power. And that 3 is where I get that exponent. We moved it over 3 places. And down here, it says we should move the decimal point 3 places to the left. So the exponent will be 3. So if you have to move it to the left, it is a positive exponent. Write that down. Positive exponent. EXP stands for exponent. So that's where we get this number. So let's do another example like that. Look at number 3. Okay? Number 3, the decimal is at the end. There is not a decimal, that is a comma. Okay? So we want to put the decimal where it'll be one number and then a decimal. So we want to put the number, the new decimal goes here. And there are 1, 2, 3, 4 places in the middle there. 1, 2, 3, 4. Okay, so our new answer is going to be 5.582. You can put the 0 times 10 to the 4th power because we moved it over 4 places. Okay. Here's one more over here, just like that. This number 2 is 902. We want it to say 9.02. So we got to figure out how many places we're going to move it over to be our exponent. So to get it from 902 to 9.02, 1, 2. Okay, so 2 places. Okay, now let me show you the opposite direction. If you have a large decimal, like in this example in number 1 and number 4, you want to get it into a non-decimal answer. You're going to move the decimal the opposite direction. And when you move it to the right, it is going to give you a negative exponent. Okay, so let's see here. You start with it right here, 0.087, and that becomes, the decimal moves right here. It becomes 8.7 times 10, and let's count how many places. 1, 2, 3. 3, but remember, and when you move it to the right, it's negative. So it is negative 3. So let's do an example down here. we want this one to say 2.59, okay, because that's our pattern. We want one number in front of the decimal and the rest of the numbers after it. So in order to do that, we have to move the decimal 2 places. Times 10 to the negative 2 because we moved it to the right. Down here, our number is going to be 3.15, and it is going to be times 10. Let's see how many places. 1, 2. Oh, whoops. Nope. Miss Hogg was wrong. Just one place over would be 3.15. And so it would be -1. Now, I want to show you how you can check your answers. Okay? You could check your answers in your calculator by entering your answer and seeing if it gives you what you started with. So 2.59 times 10, housetop or caret. Remember the little caret button that we learned yesterday? Makes exponents. To the negative symbol is below the 3, 2. So just put that 2.59 times 10 to the negative 2. That's what I have here. And enter. 0.0259. 0.0259. That's what I started with. So that one is correct. And to check the other way, you do the same thing. Enter in your answer. 9.02 times 10 to the second power. 902, which is what we started with. Okay? So that is how you check that. You can do the rest of these on your own. Now, let's go to the back. Now the back is the same except for we're starting with scientific notation and we want to go to standard notation. So it's like working backwards from the front. So here they give you the number in the exponent form. So this one is 3.25 times 10 to the second. So you're going to have to move the decimal backwards. Okay? So you'll move it back 2 places because that's your exponent. And you get 325 point. And that's just 325. Over here, same thing. You got 8.76 times 10 to the negative second. So when it's negative, you move it this way. 1, 2. And you get 0.0876. Now, notice here, when they moved it 1, 2, okay, they didn't have a number here. They had to put a number, a filler 0. That you might have to do that in some cases where you have to move it to the left. So let me do one for you, and then I'll show you a shortcut on the calculator. 9.63 times 10 to the negative third. Well, on this side, the negative answer is when you move it to the right. Because it's backwards from what we had before. So that means the left is when you have a positive exponent. Okay, so here we have 9.63 times 10 to the negative third. It's a negative exponent. You're going to move it to the right 3 times. 1, 2, 3. Okay, and so you get 9. You have a filler 0 here. 9630. Okay, and on this one, it's a positive exponent, positive 3. You're going to move it to the left, okay? So it becomes 1, 2, 3, okay? So you have 2 filler zeros, 0.005146 is your answer. And let me show you how to check those. On your calculator, I'm going to do this one. You put in your original number. So 9.63 times 10 to the negative 3, and it gives you your answer. Okay, it looks like Miss Hogg messed up on that one, which happens. Okay, just checking to see if you're paying attention. So let's see here. On this one, it says that I should have gone the opposite direction. Okay,